So the second method for solving systems of equations is called elimination. And this one is much nicer to avoid fractions when you don't have something really nice to use substitution with. So if you have a system of equations where you've got a coefficient of 1, substitution works really great. But if you've got systems of equations where your coefficient isn't 1, then you don't really have such a nice question. So let me show you how this kind of works. Let's say that I had something like yesterday's question where we had x plus 4y is equal to negative 1, and then we had 5x plus 2y is equal to negative 14. So yesterday I showed you how in equation 1 you could solve for x, and then you could use substitution. The idea behind elimination is this. Set up your equations so that you can add or subtract your equations, kind of like you did in elementary school, adding and subtracting up and down, to eliminate, that's where you get the name from, one of the variables. So if you're dealing with x and y, you want to set it up so that you can add them or subtract them to eliminate the x or eliminate the y. So what we want to do with this one is I said x plus 4y is equal to negative 1, and 5x plus 2y is equal to negative 14. If I draw a line underneath these, and if I added these right now, I'd be adding straight down, and I would end up with 6x plus 6y is equal to negative 15. And this still has x's and y, so this is not elimination because these are not eliminated. Whoops. So what we might have to do is we might have to take our equation and multiply by something or divide by something to make things easier to eliminate. One of the possibilities for this is that I could take equation 1 and I could multiply the whole thing by 5. So multiplying everything by 5 is just bringing it up by a scale factor of 5. This is what our new system would look like. It would be 5x plus 20y is equal to negative 5 here. And then the second equation doesn't have to change, so 5x plus 2y is equal to negative 14. And then if I drew my line sitting underneath like this, what I could do is I could take a look at it and say, hey, look, if I subtracted these two equations, 5x minus 5x is nothing. It disappears. 20y minus 2y is 18y. The equal signs stay where they are. Negative 5 minus negative 14, be careful with that one. That's negative 5 minus negative 14, so that's negative 5 plus 14, so that's 9. We divide by 18, and you end up with your y is equal to 1/2, like we found yesterday. When we are going back to plug it in, you can still plug it back into any equation that you want, such as x plus 4y is equal to negative 1. So x plus 4 times 1/2 is equal to negative 1. X plus 2 is equal to negative 1. X equals to negative 3. And we still get that same solution as we did, 1/2, not 2. We got the same solution as we did yesterday. So the other thing that you could have done is you could have done this. Let's say we had x plus 4y is equal to negative 1. And we have 5x plus 2y is equal to negative 14. And let's say you don't like subtracting. Well, here's another option. Why don't we take the second equation and multiply by negative 2? Let's see what happens. I've got x plus 4y is equal to negative 1. I've got negative 10x minus 4y, so negative 2 times positive 2 is equal to positive 28. And in this case, because the signs are opposite, if I add the two equations, positive 1x plus negative 10x is negative 9x. Positive 4y plus negative 4y disappears or eliminates, and negative 1 plus 28 is going to be positive 27. Divide by negative 9, divide by negative 9, x is equal to negative 3. Again, plug it back into one of the equations sitting in here. Negative 3 plus 4y is equal to negative 1. Add 3 to both sides. 4y is equal to positive 2. Divide by 4. Divide by 4. Y is equal to 1/2. And we get that same solution, negative 3 comma 1/2. So the idea behind elimination is to take your equations and set it up so that you add or subtract to get yourself your equations. The second example that we did yesterday looked something like this, and it was x over 2 minus y plus 1 over 3 is equal to 1, and x plus 2 over 4 plus y over 5 is equal to 3. What we did was the first one was we got that common denominator of 6. So we had 3x minus 2y plus 1 was equal to 6 over 6. And the second one, we got a common denominator of 20. And we had 5x plus 2's and then 4y's is equal to 3 over 1 times 20 was 60. So this is what my equations look like. 3x minus 2y minus 2 is equal to 6. Or even better, if I keep moving with that one, 3x minus 2y is equal to 8. It's very important that you keep your equations set up very consistently. Usually what I like to see is the x's and then the y's and then the equal sign and then your number. That's for equation 1. For equation 2, what we've got right here, we've got 5x plus 10 plus 4y is equal to 60. Which means that 5x plus 4y is equal to 50. And that's my new system right now. So looking at this, here are my possibilities. I could multiply equation 1 by 5 and equation 2 by 3 and get those x's to match. I could multiply equation 1 by 2 and get my y's to match. That seems like an easier thing to do. So again, there are lots of different things that you can do. You can affect both equations by multiplying by something, or you can see if you can just do one equation by multiplying by something. But the idea is that you have to match up the coefficients on either the x's or the y's so that they will eliminate. So I'm actually going to take this second equation and I'm going to multiply by 2. So I get 6x minus 4y is equal to 16. I'm not going to do anything to this one. I've got 5x plus 4y is equal to 50. And in order to eliminate the y's, which is the one that are matching up, I have to add these two equations together. 6x plus 5x is 11x. Negative 4y plus 4y is disappeared. 16 plus 50 is 66. Don't divide by x. Divide by 11, and you're going to get x is equal to 6. You can plug it back into whatever equation that you want. Maybe I'll just use this one right here. So 5 times x plus 4y is equal to 50. So 30 plus 4y is equal to 50. 4y is equal to 20. Divide by 4, y is equal to 5. And so my answer, and don't forget what you're doing when you do these questions. You are trying to find the point of intersection between these two lines that we're setting up. So that point of intersection happens when x is equal to 6 and y is equal to 5, or the point 6 comma 5. All right, so it is time for you to do your practice questions. And your homework is going to be day 2. Again, please make sure that you're keeping in check with Teams for any announcements or others.